right, we're on pre-calculus lesson 22, question number 8. We're solving radical equations, and our process was to isolate a radical, square both sides, and solve by whatever method you need to solve by. But if once you square a radical, there's another radical, then you need to isolate the new radical and square both sides, and you continue that process until no radicals left. Okay, so number 8, we have an isolated radical really on both sides. So we're going to square both sides to eliminate the radical situation. It's going to cancel that outside radical, and that square is going to cancel that radical. And we're going to have 3 square root x plus 1 is equal to 3x minus 5. You understand that? So we squared both sides, and the outer radical on the left was canceled, and the radical on the right was canceled. Now, we've been left remaining with a radical, so we have to isolate that radical. To isolate that radical, we're going to undo multiplication by division. And so we will have square root of x plus 1 is equal to, if we distribute that 3 through the understood parentheses, x minus 5/3, leaving it as an improper fraction. So we had an isolated radical. We squared both sides, but then it produced another radical. So we isolate it, and then we're going to square both sides again. Now that square cancels the square root, and we get an x plus 1 over here. On the right side, we're going to have x minus 5/3 times itself, x minus 5/3, which is going to be x squared minus 10 thirds x plus 25 ninths. Understand that? You would have 2 of the middle part. You'd have 2 of the negative 5/3 x's, which would make negative 10/3 x. So we have equal x squared minus 10 over 3x plus 25 over 9. So that's what we've got so far. Let me see that. I'll let you catch up. We've got a quadratic, so we have to set it equal to 0. So we would subtract x and subtract 1, subtract x and subtract 1. With those x's, if we use a common denominator, we have negative 10 thirds x, and the negative 1 is negative 3 thirds x. And when you put those together, you get negative 13 thirds x. Everybody happy with that? So we're going to have x squared minus 13 thirds x on the x's. And then on the numbers, we have 25 ninths minus 1, and 1 is 9 ninths. So 25 ninths minus 9 ninths leaves 16 ninths. So plus 16 ninths is equal to 0. Now, we really don't like those fractions very much. So we're going to fix that problem. We're going to multiply through by the common denominator between 3 and 9, which is 9. It's really nice that on the right side it's going to stay 0, you see. And so we're going to have 9x squared, and then 3 goes into 9 3 times, and that 3 times that 13 is the 39, so we have minus the 39x. Everybody say we got that? The 3 on the bottom goes into the 9 3 times, and that 3 times that 13 is a 39. And then this 9 will cancel with this 9, and we'll have a plus 16 equals 0. So now we've got a quadratic to solve, and that quadratic has big numbers, and a is not 1, so the little easy method is not going to work. And factoring is going to be pretty large, and it could be kind of crazy if you look at the original problem. but we don't know that it's going to be crazy. We're going to use the quadratic formula anyway just because there's a possibility it could be crazy. And factoring, we would be dealing with huge numbers. So we're going to plug that into the quadratic formula, which remember was x equal negative b plus r minus the square root of b squared minus 4 times a times c all over 2 times a. So we plug it in and we're going to have x is equal to the opposite of a negative 9, 39. The opposite of a negative 39 is a positive 39 plus or minus the square root of my b, which is a negative 39, so we put it in parentheses square, minus 4 times my a value of 9 times my c value of 16 all over 2 times my a value of 9. Now remember, there's the possibility of square root answers, radical answers, or even imaginary answers. And so to see the real answers, we want to work it down instead of throw it in the calculator. We know that we can do the negative 39 squared. We can do all that multiplying. We can do the denominator. So we're going to have x equal 39 plus or minus the square root of, what's 39 squared? 1521, and then 4 times 9 times 16 is 576 over 18. Now we're going to do the subtraction in there. We'll have x is equal to 39 plus or minus the square root of 1521 minus 576 is 945. Now, I'm going to erase the whole right side. Is everybody done with the right side? The square root 945 might break down. So we're going to have to write it as a radical. So we're going to do some radical work here. I'm going to come over here to the side and do that. 945 divided by 3 is 315. Divided by 3 is 105. Divided by 3 is 35. Divided by 5 is 7. Remember the prime factorization method of simplifying a radical. And then we would rewrite it as the product of its primes, 3 times 3 times 3 times 5 times 7. It is square root, so you circle sets of 2. I'll let you catch it. From each set of 2u, bring 1 from the set out. What did not get circled in a set goes back in. And you multiply. And you're going to have 3 square roots of 105. So square root 945 simplifies to 3 square roots of 105. So we have x is equal to 39 plus or minus 3 square roots of 105 over 18. Let's see how we got to there. Now, there's 3 terms in this whole problem. There's the 39, there's the 3 square root 105, and there's the 18. Notice that all 3 of those are divisible by 3. 3 goes into all 3 of those. Since 3 goes into all 3 of those, we can simplify that into x is equal to 39 divided by 3 is 13, plus or minus 3 divided by 3 is 1, so we'll have square root 105, over 18 divided 3 is 6. So we reduced by dividing each term by the greatest common factor 3. Let's see, we got all that. Okay, I'm going to make that go away. So we have two possible answers. We have x equal 13, go the plus route, 105 over 6, or we'll go the minus route, x equal 13 minus square root 105 over 6. But guess what? We got to plug them in to see if they work. That's going to be pretty, but it's okay. So we've got to take each of those and plug them in. We'll take this and put it in place of the x here and there to see if it comes out equal, right? Now that part we will do in the calculator. But we're going to have square root of 3 square root of x. Now what am I going to replace x with? That whole mess right there. So that x gets replaced with 13 plus square root 105 over 6. And after that x, I still have a plus 1 in there. Yes. You're stretching. Okay. And that needs to be equal to the square root of 3 times. Now, that's x. That's times x, and my x has a plus in it, so I need to put it in parentheses. 13 plus square root 105 over 6. So I have 3 times my x replacement minus 5. Now, you're going to stick that in the calculator. And when you stick it in the calculator, it's going to look like this with an open parenthesis, right? And then a 3, and then another one with an open parenthesis. And then you have to put the numerator in parentheses. And then you got another square root with a parenthesis. And then you have to close that parenthesis. And then you close the numerator. And then you divide by 6. And you close that one. And then you do a plus 1 and you close that one. So that's going to look like when you type it all in, right? Let me make sure this is opened here and closed here. This one is opened here and closed here. This one is opened here and closed here. And this one is opened here and closed here. It's kind of crazy with the parentheses. But when you hit enter, you get, I've gone and done it, 2.57361, 2.57361, 135, etc. And when you do the other side, you get 2.5361135, etc. And so it checks out. So this one is a solution. So then you'd have to plug the other in and try it. When you plug the other in and try it, when you plug it into the one on the left, you get 1.9 something. And when you plug it into the one on the right, you get an error, which means the answer has an I in it somewhere. And so the second solution is an extraneous solution, so we have to cast it out. So you would still get those two. You would plug them in. When you plug the first one in, you would get the same thing, so it works. When you plug the second one in, the minus version, you get 1.9 something on the left. You get an error in your calculator on the right, which means there's an imaginary answer. They don't work, and so we call that an extraneous solution. Any questions on number 8? Well, that's the end of what we're doing here on the algebra half of pre-calculus, and then after this, we'll go to the trigonometry half. All right, appreciate your attention.